Okay, today we're going to talk about infinite geometric series. Remembering that a geometric series has a R value, which is a common ratio. And we're going to talk about a little bit about finite and infinite. So finite series is one that ends. So for example, 1 plus 2 plus 4 plus 8. That would be a finite geometric series. But the infinite series is one that never ends. It goes on forever. Okay? We're going to talk about how to find the sum of an infinite series. We have two goals for this. The first is to decide whether a series is convergent or divergent. I'll define these terms in a lot of detail in the next few slides. And then we're going to create a formula for determining the sum. This of an infinite geometric series. You'll see that this is actually not much different than the other formulas we've already used. Okay, so let's talk about convergent and divergent. Let's start with convergent. I think of the word convergent to converge. Okay, that means it heads towards someone. So let's say if we look at this series here, 4, 2, 1, 0.5, and so on. You'll see that the first term is 4, and the common difference is 0.5. There's the common difference of 0.5. Now I used our formula that we had for geometric series so that the sum of a geometric series is the first term times r to the power of n minus 1 divided by r minus 1. I used that and I found the sum of all of this. Now, what do you notice about this sum? I want you just to look at it and really think about it. Notice how it's getting really, really close to 8. Okay? It's not getting bigger. It's not getting infinitely bigger. So now if I look in a difference, if I look over at the divergent series now, so for example, here's a series and it's divergent. Okay, it's 4, 8, 16, 32. Here's the first term and here's the common difference, 2. And if I look at these, the sum of the third is 28, the sum of the 10th is 4,092, the sum of the 12th is 16,380. You'll notice that this sum is just getting bigger and bigger and bigger and bigger. Now, if we look at the graph of both of these, it actually shows a little bit. So if we look at the graph, so I just took a simple graphing software and I put in this series, and you'll see what happens to the convergent. It goes like this, and it sort of levels out. But the divergent goes up and 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 just goes on forever up. Okay, that is really the key to this. Now, I want you to stop here, and I need you to write this down. Okay, a convergent series. If I look up here, look at the value of r here. It's 0.5. If I look at the value of r here, it's 2. Okay, so if the value of r is between -1 and 1, that means if it's a fraction, if it's a fractional number, then it will be a convergent series. Divergent, on the other hand, is all other values of r. So it could be -2. It could be, r could be 20. Okay? Now, it's important to know that our sum of our geometric series, we can only find the sum of a convergent series. A convergent geometric series. That is the only time we can find the sum. So our first goal whenever we look at a series is to decide whether it's convergent or divergent. That's the first thing we have to do. You probably want to stop the video and write down that you can only find the sum of a convergent geometric series. Okay? Now, let's talk about convergent series and divergent series. Here's the actual written definition that I want you to write down. Okay, a convergent series is a series with an infinite number of terms, right? So that's what we're talking about. Series is with infinite number of terms, in which the sum of the partial sequence approaches a fixed value. Just like in that last example, it got it got a lot closer. It kept getting closer and closer and closer to 8. Okay? Now, divergent series, on the other hand, it's still an infinite series in which the sum of the simply gets bigger and bigger and never approaches a fixed value. Okay? We do not know how to find the sum of these. We do know how to find the sum of these. Okay? Important. We can find the sum of a convergent. We cannot find the sum of a divergent series. So the key to a convergent series is that it must have a common ratio that has a value between -1 and 1. You need to write that down. A convergent series has a common ratio between -1 and 1. That means it must be a fraction. Fractional value. So the next step, if we go back to our first slide and we see what our goals were, we've now decided how to figure out if a series is convergent or divergent, and then we need to create a formula for determining the sum. So that's what we're going to do now, create the formula. So here we go. We're going to develop the formula for finding the sum of an infinite geometric series. We go back to the formula for finding the sum of a geometric series. There it is. Now, as n gets bigger, you'll notice that Rn becomes closer to 0, because if it's a fraction, if it gets bigger, that means it gets closer. You notice that? It's getting closer to 0. And if it keeps going and keeps going and keeps going, it approaches 0. So when it gets to infinity, it becomes 0. So that means that this part of the whole thing becomes 0. Now that makes this -1 left over. So we can rewrite this as, okay, so this part is t1 times -1 over r minus 1. Now I don't like having this -1 here, so we're just going to rewrite it slightly. Okay, and if this, so the sum of an infinite series, geometric series, is t1 over 1 minus r. That just gets the sign right for us and we don't have to worry about it. But there's the formula, simply because this part here becomes 0. So you need to stop it and write down the formula. Again, this is only for a convergent series. So for convergent. So we're going to do a couple of examples just so that you get comfortable using this formula, and then you can try the quiz. Okay, so the first step is to decide if the following is convergent or divergent, and then state the sum of the series if it exists. Again, if it's divergent, it will not exist. So I wrote down the formula for you so you have it. Okay, so the sum of an infinite series is the first term divided by 1 minus the common ratio. So let's look at A. What is the first term? It's 1. And what's the common ratio? Now you should stop the video now and actually figure out what the common ratio is. But I'm going to just write it down. It's -1 over 3. Now it's a fractional value, right? So that means that this is a convergent series. It means it's convergent. I'm just going to erase that so that I can rewrite convergent. So this is convergent. Okay, that is convergent, which means that it has a sum. So we can use the formula up there. We can say S infinity is the first term, which is 1, over 1 minus -1/3. Okay, now take a second just to try and simplify that on your own. And I'm going to actually do the math here. So it's 1 divided by, so 2 negatives makes a positive. So 1 plus 1/3 is 4 over 3. And if I'm dividing by a fraction, that means I invert it and multiply. So that would be 1 times 3 over 4. So the sum of that is 3 over 4. That is the sum of that series. Now, in this case, T1 is 2. But again, that's not the important part. The important part is looking at the R value. In this case, the R value is -2, which makes it a divergent series. That means that it's not going to have an infinite sum because it's going to get very, very, very big, and we cannot find it. So if it's divergent, you cannot find it. And that's it for today. So I want you to try the quiz on finding the sum.